This week, we are going to be analyzing what weather is like in the lowest layer of the atmosphere, in the troposphere. We're going to look at different clouds, and we're going to look at weather fronts. And by the end of this, you should be able to look at this map and know what the weather is in a location. So you might have seen a map like this before if you've ever watched a weather presentation on a news show like on WBKO, or maybe your parents look up maps like this, or maybe you've seen a pilot look up a map like this to know what is coming. This is called a weather map. By the end of this week, you should be able to use this weather map to explain weather patterns, and you should also be able to see high and low pressure areas as well as fronts on a map and predict the weather. Now, a lot of what we're looking at is going to be about atmospheric pressure or air pressure, which we talked about when we looked at the layers of the atmosphere. Air pressure decreases as you get further above Earth's surface. So it is the pressure caused by the weight of air above an area. So as you get higher and higher above Earth, you increase in altitude, pressure is going to decrease. This is measured by a barometer, and it is measured in the unit millibars. The air pressure pushes down on the mercury in the barometer, which pushes it into the tube, which allows us to measure it. There are two types of pressure systems that we're going to be looking at. The first is a high pressure system. This is caused as air cools down. And if you remember from our States of Matter unit, when air cools down, it gets more dense because things start to pack together. And if it's more dense, it's going to sink towards Earth's surface. This is going to cause a spinning clockwise, okay? The next is low pressure. This is going to happen as air warms up because remember, as particles warm up, they start spreading out, which would reduce the amount of pressure. Also, it creates less density. So this kind of air mass is going to rise above Earth's surface and it's going to spin counterclockwise. Now, if you look on this map, you will see the capital blue H and the capital red L. The capital H represents high pressure systems, and it will always be blue. High pressure systems are going to represent sunny, clear skies, calm winds, and cool, dry air because it's the cold front coming through, which we'll talk about in a minute, and there's no warm air within it to cause that condensation. So then we have low pressure. Low pressure systems is when happens when warm air is there. And so these are going to allow for condensation. It's going to be really cloudy and stormy. These are usually your thunderstorms, and it's usually with strong winds and this like humid air. So when a high pressure system moves into your area, what kind of weather would it be? Well, we would expect sunny weather, not necessarily warm, but sunny weather with calm winds, cool, dry air, a nice day. Whereas low pressure systems, we would expect it to be really cloudy, thunderstorms, not a nice day. Now, we look at weather also through types of air masses, not just high and low pressure systems. An air mass is a large body of air with about the same temperature and humidity. Humidity is the amount of water vapor in the air. So again, an air mass is a large body of air with about the same temperature and humidity. There can be two types of air masses. There could be a continental air mass or a maritime air mass. And again, replay, go back, rewatch parts of this video to help you. A continental air mass starts over land. It starts over a continent. A maritime air mass starts over water, okay, like marine life. Cold air masses tend to come from the north, northwest. Warm air masses tend to come from the south, southeast because of the water that is there and the climates that are there. When fronts move, cool air masses, high pressure, are more dense and flow towards areas that are less dense, warm and moist. So you'll notice low pressure is usually in front of a warm front. High pressure is usually behind a cold front. High pressure areas move into low pressure areas. So if we see an H here and an L here, you're going to know that that H, the high pressure, is moving towards low pressure. Now, there are four types of fronts, which is the boundary between two of these air masses meeting because they don't all move the same direction. They're classified by which type of air mass is replacing the other. So a cold front is a cold air mass replacing it. It's represented by blue triangles on a line. The triangles can change sides based on which direction it's moving. A warm front is represented by a red line with red half circles. The half circles change sides based on which direction it's moving. A stationary front is when these two cold and warm meet. They're coming together and meet. This shows us the red and the blue together shows us that they have met, and they're always going to be opposite directions. An occluded front is when a cold air mass kind of comes in and takes over a warm one. Two come in, and it is represented by purple, and it has both the triangle and the half circle, but it's purple because it's a very different movement. So let's jump into the types of air fronts. A cold front is cold air replacing warm air. That cold air, because it's more dense, is going to push up the warm air, and it's going to increase pressure because cold air has a higher air pressure because it's more dense. Moist air is going to be pushed up. This is going to cause showers and thunderstorms along the front of the front, along that leading edge, but then it's going to be nice weather behind it. Then we have a warm front. This is when a warm air mass replaces a colder one. It kind of moves faster ahead of it because remember, warm air is more dense. The air behind the front is going to be warm and moist, and pressure is going to go down. So we would represent warm front. There would usually be low pressure behind it. These are usually slower moving, but they do cause this rise of warm air over cold air because of density. And there's going to be a lot of precipitation in a huge area with these fronts. So how are cold fronts different than warm fronts? Well, it has to do with which body of water, or body of air, not water, is replacing the other. Cold air or warm air, and the pressure is going to be different also. Warm fronts bring low pressure, which usually brings storms. Cold fronts bring high pressure, which usually means clear days. Then we have a stationary front. A stationary front happens when the boundary between two different air masses is stuck. Neither one is really strong enough or moving fast enough to replace the other, so they've just met and they're not moving anywhere. These are going to be your days where it just rains and rains and rains, unending, because it's not moving anywhere. We showed this with that line that has blue triangles on one side, red half circles on the other. The red half circles are pointing the direction that the warm air front was moving. The blue triangles represent the direction that the cold front was moving. You can see that right here in the middle. So stationary, still, they're stuck. Then we have occluded. This is more complicated, but it is when two cold air masses kind of converge on a warm air mass. It's going to rapidly push up the warm air. And because you have so much warm air, it's going to create cumulonimbus clouds, which we know are associated with thunderstorms and thunder showers. So as it moves through after the initial thunderstorm, then you're going to have clear and dry skies because of the high pressure. So looking at this map, we have high pressure and low pressure. You see the H and the L, and we are looking for where our boundaries should be. So let's draw in our fronts. The first one we're going to draw in is our cold front, and it's blue. And our cold front, remember, is going to be in front of the high pressure, and it's going to be moving towards low pressure. So we would expect our cold front to be right in here. And you can see that with these cooler temperatures, 40, 45, 39, 35. And then with our low pressure, that shows us where a warm front is. And we can see right here that our warmer air temperatures, 70, 75, 80 are right in there. So our low pressure is going to be right here, and it's moving in. Now those will probably eventually meet. And let's think about what is the weather. Right here in the middle where this low pressure is, that weather is most likely going to be rainy, right in here, cold and rainy. Back here, high pressure, we would expect it to be clear skies, pretty nice day. Down in here where the warm front is moving, we're going to expect warmer temperatures, but we're also going to expect rain because warmer air means that more water is condensing, which means there's going to be more precipitation. Remember these things as you look at maps like this one. So on this map, there are lots of things going on, but let's specifically look at the weather where we live on this day. So Bowling Green is right in here, right in this area. And what has just passed through? Well, we see these blue triangles moving this direction. And so a cold front has just passed through. And that makes sense because yesterday it was really rainy. It was the warm air mass being pushed up. And today, by the end of the day, it's supposed to be clear skies, but we have much cooler temperatures. So a cold front is moving through, and notice what's right behind it? High pressure, okay? So as you work today, think about what those fronts mean. If you need to replay this video so that you can remember all of those things, that would be a very smart idea. Happy weather reading. I know that you all are going to be great at reading weather maps by the end of this week.